recording. All right, and I trust everybody is seeing the splash screen there that starts things up. Welcome everyone to the August 2023 meeting of the Seattle Robotics Society. Man, this year's flying by. Not too much of it left, past the halfway point. So let's see here. There's what we're typical agenda there. I won't go through that in detail because most of you are probably familiar with it, but we'll just kind of march through things here. Got a lot of club business stuff and events of note to talk about here up front. So let's see, just for general reference, anybody, if you're not currently actively speaking, please mute your microphone. So if any background noise behind you and stuff doesn't, the dog starts barking, the kids start crying, somebody drops a gigantic glass bowl of water right behind you and you fly through the air, and so we want to avoid having too many surprises during our meeting here. Now, although that would be very amusing, I think I would capture that in a video and put it up on YouTube. So anyway, thank you. And we're going to have got a fair bit to kind of a handful of things to chat about here with regard to the meeting location. The plan, at least the general plan, is to potentially start in-person meetings, but really only if that kind of makes sense. We sort of need to have, I don't know what a good minimum quorum is to say, okay, here's enough people that want to do in-person. Let's restart these things. But we could certainly entertain those ideas. Let me see here. I've got, okay, let's see. Yeah, you guys, I don't know how many of you have any idea where this location is. I know Donna and Lloyd have been there, and it's about a mile kind of southeast of where the original previous location was, first facility that we used to meet in. So it's kind of back, sitting right next to the railroad tracks. Let's see. Yeah. So the most, for the most part, I will be hosting these meetings as I can. However, I am going to be tied up for the most of the time on Saturday mornings, third Saturday mornings here for a while. So there'll be other people that'll be running the meetings, but our plan is to just continue having these things month to month as we have been. Let's see. Yeah, meeting facilitators. So I know there's some of you have done it. I know Lloyd's done it, Donna's done it. Richard Greenray said he would do it. We would love to have any other people that are interested, or we've all have experience running online meetings now, so it's not a particularly big deal. And I usually do all the prep for you. So I set up the slides and all that stuff, and all you have to do is just run the slideshow and talk. So that's something you can do. Let me know. Let's see, the potential for, we want to stream our in-person meetings. However, they're, and we can, I guess, I don't know if you want me, Lloyd, if you want me to talk a little about the facility. You've actually seen it. You want to chat a little bit about the location, what we can do in terms of in-person meetings?
Yeah, I can talk about that. And Donna, feel free to chime in if you'd like to as well. So basically what we've got is the new facility. It's down in Kent, as Steve mentioned. There's two areas. There's a warehouse area and a office area. The warehouse area is very much like we had at the original field house. It's a little smaller and it's a little, set up a little different. We only have access to that, however, when they're not doing first WA competitions. The way they're setting up for first WA, they're basically going to have competition fields and stuff that kind of take up the whole place. The office area, however, is available to us, it sounds like pretty much year round. And they've got a teleconferencing setup, which is it's an Intel NUC with a camera and a mic and a, screen all set up. So what we could do there is for about 6 to 8 people, they could meet in the office area and kind of do an in-person aspect, and then just be a remote node to our general hybrid meeting. And that that would be that's another dimension of it. So there's a couple of ways we could do this. The other thing that Steve and I were talking, and Donna and I have also talked about, is we also have the capability at this point to do kind of keep doing the meetings remote, but maybe once a quarter or something have a just a kind of a special in-person thing where we go down and do a little in-person workshop, or we do run some robots, or we come up with some activity and do it together as a group. And that would probably be in addition to a meeting. So that's another possibility.
Mm-hmm.
So I guess, I don't know, I kind of did a poll just of the folks that are online here. How many people, and let's see, do this with by raising your hand. Folks know how to vote that way. Does anybody chime in if anybody does not know how to vote that way? Okay, so go ahead and just raise your hand, and how many people are interested in going back to an in-person meeting? Okay, so I'm seeing 0 so far. If somebody's not getting registered, go ahead and open your mic and speak up. I just want to make sure we're getting an accurate poll.
I would be.
Okay, so 1. Okay. Okay, cool. Thanks, folks. That gives us the information we're looking for.
You can, and if you change your mind or whatever, hit our email, Seattle Robotics Society @gmail.com, and just let us know. Like Lloyd says, that the facility is, the office area that we have is not very big, and when we were meeting in person before, we could have 25 to 30 people. I'm pretty sure that many people will not squeeze into that office area. So
no, the office is going to be limited to 10 max.
Probably 10.
I think
yeah.
eight is probably more realistic. So
yeah. So
another. Oh, I'm sorry, Steve. Please go ahead.
Go ahead, Donna.
I was going to make a comment too about the warehouse area itself. So as Lloyd was commenting, it's very much the same type of design as what we had at the previous location, but maybe a little bit smaller. What I liked about, as far as the idea about running workshops, like robot type workshops, or like mini events, contest events, that type of thing, is that there's for whenever we can utilize when First Law is not actively using the area and we have access to it. There's a great big large footprint area that Lloyd and I were showing, where we can utilize that facility, and it's it's a nice size. It'll be real nice for us to run workshops and events utilizing that space. So I think all that will work out well.
Mm-hmm. Okay. Anybody have any questions? Anybody floating around out there? Okay. Let's see. I guess I should probably. Actually, I neglected to mention. Okay, yeah, there's some stuff under the. Okay, and if you have questions or whatever, I just opened my chat window. I should have done that right at the start of the meeting. So if you do have a question or something, feel free to just pitch it into the chat. I'll try to keep my eye on that, and any kind of information you want to share with everybody, put it in there, because that will go into the post for this meeting along with this video. So kind of get both the text and the video audio. So did anybody make it to the BrickFest Lego show in Puyallup here last weekend? that was kind of so it seemed to be a pretty big deal. I'm sorry, of course, I don't no longer live nearby. So, I mean, I would have loved to taken my kids or grandkids or somebody to that, because Lego shows are they're a blast. Okay. Any other activities, any other things that people are aware of that's been going on lately they want to share about?
Started?
Yeah. Okay. Now we'll just roll on here. I just happened to was kind of looking at maker spaces, and I mean, many of you are probably aware of at least some of these, if not all of them. So these are various maker spaces around the Seattle area. There may be even more, for all I know, but these are a new one that apparently has come online here is down at the Federal Way Public Library. At I think that's right along. It's up right on. I believe that's the one that's right on. Let's see, Pacific Highway, if I'm not mistaken. I think it's not far from the Federal Way High School. And the description of the stuff that they have available is really pretty amazing. It's kind of an interesting thing that the libraries have jumped onto this bandwagon. And this Cremaker space is apparently a new one that just started over in Renton. So these slides will be available, and these are clickable links. So in post meeting, you can go ahead and check these out. Although you can see the links there to these things. The Seattle Makerspace, I think that's down at the base of Queen Anne Hill, or near the base of Queen Anne Hill in downtown Seattle. Not sure where this one is, the Airlight Time Space Seattle, but it's in the city. And then there's one up in North Seattle. So anyway, there's a variety of those kinds of things. If you don't, if you're looking for a space to be able to access a lot of cool tools that you might not already possess, it's an option for you. Let's see, Maker Faire on Mare Island in the Bay Area is coming up in October, and I know James Newton is he's a big fan of the Maker Fairs, and he was particularly interested in this one. So if you have a occasion to be in the area at that time, or you happen to go down there for any particular reason, that was a fairly large Maker Faire. There are other events that you can look up online. The Robot Events website, I think it's I believe it's robotevents.com. Yeah. And that will gives you, it looks like you got competitions, VEX drone competitions, workshops, all over the country. So that's a kind of a cool website for just finding out what's going on anywhere and everywhere. Pretty cool. Robo Games 2023 is coming up in Pleasanton, California. And then the Snowco Makerspace meets pretty regularly. There's people up there, I think they're up there every week. So they also they have remote meetings as well. So they do Zoom, so you can actually remote into their meetings. So look those guys up online and see how you do that. Let's see, the other piece, I guess, is our upcoming event, and I'll let either Donna or Lloyd give us any updates on this. So,
you want me to do it, or you want to do it, Donna?
Why don't you go ahead and start it off, and I'll add any commentary at the end. How about that?
Okay, so coming up on September 9th, there's might be a little hiccup on this, so we'll double confirm. We're still getting the venue pinned down. But anyway, September 9th at Sunnycrest Elementary School, we're going to do a Robo Magellan Plus. This is going to be our first in-person event since COVID. It's going to be a little smaller and less formal. But basically, we're all going to kind of converge on Sunnycrest Elementary School. We're going to do a Robo Magellan run. We're going to have the new, what do you call them, Donald?
Let's see, the SRS build challenges.
Thank you. SRS build challenges. line maze, and
And mini sumo.
mini sumo. We've got people participating so far in everything except line maze, and I think one of the build challenges. That's still valid, Donna?
No, let's see. There are contestants for each level,
You
I
got-
believe, of the build challenges. Yes,
Okay, so we got contestants for basically everything except line maze then at this
correct.
point.
Correct.
Okay, thanks. And it'll be kind of an all-day event. I think we're 9 to 3 or something on that order. And
Yep.
so, yeah, come on down, bring a lunch. We won't be, we won't have a venue quite like at Seattle Center, but bring your lunch and we'll catch a little sun and do some robots. Oh, we are also looking for volunteers to help out the day of on that one. And oh, awesome! Thank you to whoever's putting that up.
That's me. So
Thanks, thanks, Steve. Yeah, so it's I'll note Bob Cook is actually going to come down from Canada and bring Thin Man again. So if you're looking to take another swipe at Thin Man, now's your chance. Anyway, we are looking for some volunteers to help out that day. If you'd like to, help run competitions or just generally do any of that, please let Donna or myself know. And am I missing anything?
Let's see. So one thing to do about the venue, that elementary school, is going to be completely outside for the idea about COVID protections, etc. No inside access at all into the school. And it's a beautiful area as far as the setups that are possible for these outdoor contests, namely the build challenges and Robo Magellan. So if nothing else, if you don't plan on competing that day, I think it'll be a fun and informative change for all of us SRS members to come and see this new facility. I think everyone who attends will be massively impressed for what we can do there. And
it's
so it'll
really nice.
It's
There's a lot
really,
of space.
yeah, there's a lot of space, and where it's going to be, we can, as we grow with our entry skills for the various contests, it's an easy venue to, I'm sorry, I'm struggling with the words this morning. It's a great way to up the level of the type of course that the robots will need to navigate. So it's going to be fantastic.
And kudos to Donna for finding this place. I mean, granted, it's close to her, but she found it. She got the initial legwork done, and yeah, so good find.
So just a general question. So do you you have some kind of arrangements for, is there no access to the restrooms at the facility?
Oh, right.
Oh,
so we
so
so we got a port. Yeah. So we're going to do porta potty type of facility for that. Okay.
Okay.
Yeah.
Yeah, the school will frown upon us, going into the bushes. So we'll handle that.
Yeah. Right. Yeah. Aside from that. And then on the website, I have two separate links regarding the September 9th event. One of them is to actually for registration details, gives the full itinerary of all the detailed plans for what we're going to do when on event day, and all the details for this particular events and the registration form. So that's one link that's on there. The second one is kind of gives the information and the protocol for what to expect when you attend, either as just a regular visitor, just someone who's just there to view the event, versus people who are actually going to be competing that day. So there's two different categories of information that we all need to know, and just information about what we need to bring, since it is all outdoor and there's very little actual quote unquote facilities that will be there. So please read both of those areas of the site. besides on the homepage itself, as Steve was showing us, I'll keep updating the registrations for who's registered for what. And
Yeah.
registrations officially close on September the 4th for all the events. Okay.
Okay. Any questions or anything from anybody?
Good on my side.
All I can say is please consider, I think there's still enough time, especially since we're on a weekend right now, to get going on putting a robot together for one of these events. The build skills vary across the board. Lion maze and mini sumo probably being the best entry level contests for participation. Whereas then we've got higher level skills required for the builds, namely Robo Magellan and the build challenges. So there's a whole range of opportunities there to get your feet wet with actually building, getting in there and building, and then the awesome funness that we all get, both as the viewer and also as the builder, in actually participating in these events, for watching your robot do its thing. So please consider getting your builds ready and getting your registrations done. And I will process those ASAP.
Okay. Thank you, Donna. All right. Online presentations. So I encourage members to look for interesting folks. Web searches are wonderful. We can bring people in from pretty much just about anywhere in the world. So there's a there's a sliver kind of in Eastern Europe, across Asia, where the time zone differences between here and there get to be a little tricky. And sometimes we can work something out for maybe a special meeting time to make that happen. But if you come across somebody that you think would be an interesting, could do an interesting presentation for us, feel free to capture any contact information and send that on to the email address there on the screen, and I'll reach out to them. Got a bunch of invitations that went out here recently, and I've had a couple of responses. One was kind of interesting. It turns out that it was let's see, it's called let's see, Black in Robotics, and what that is these are Folks, Black, who have various skills and experience in robotics. Yeah, across the the spectrum of robotics, and they work through a speakers bureau, and if anybody knows anything about speakers bureau, that usually means dollars. So I have no idea how much these folks actually cost to come, but it was suggested that I could probably, if I reached out to these individuals, I might be able to find somebody who'd be willing to come non gratis and talk to us. So, because we don't have a speaker budget, unfortunately. Kind of wish we did sometimes, because there's a lot of interesting people out there that we could probably snag. But then again, some people, as some of you know, if you're, paid speaking engagements can be quite lucrative in terms of the cost, the money that you can make doing that. And that's because we're probably not really at that, looking for people of that caliber for this kind of thing. But we would, but still, fortunately, we've been able to find people that are willing to just join our meeting and tell us about what they're doing. So anyway, feel free to even reach out to these people and introduce yourself and introduce the Seattle Robotics Society and say, hey, we got this group of people that love to hear about interesting technologies and robotics in particular, and you think it might be something you might be interested in, joining one of our online meetings and talking to us. And if you get a positive out of that, just get some contact info and pass it on to me. So, and let's see. Open discussion stuff. You know, we haven't done one of these in a while. I don't actually have, well, I do have several of them that have been done in the past that probably there's been enough changes. You know, this fields of technology is constantly evolving. So, I mean, you can take a discussion about something and, you know, do it again and have an entirely different discussion because of all the changes that have happened. So, anyway, but these are options for just having a kind of a general discussions where we just need a facilitator, and anybody could lead this, by the way. You don't have to be an expert on any of these particular things, and or whatever the topic is. Just facilitate the discussion, maybe go find some videos, some information on the web, conjure up a few questions, and then we just sort of chat and, you know, share information, share knowledge, share questions, and just, you know, see where it goes. It's can be kind of interesting and fun. We've had some really cool discussions. This is the lineup that is currently coming. As you can see, I'm working to fill out the rest of this year and then start working into next year. So I'm going to continue to work on that. I actually would have to look up. Let's see, I can do that, I guess. I don't know how many of you, hopefully you've maybe at least looked at the website of of today's presenter to see what he's going to talk to us about. It's pretty interesting, actually. And that IFOR is a compressed acronym for Iterative Flow Minimization for Robotic Object Rearrangement. So that'll be that's what which comes up at the top of the website there, and so that will be we'll be hearing a little bit later. And I don't know if I've seen him. I don't see him online yet, but he will probably be here and should be here before our actual presentation starts. So let's see. Yeah, so this is just a kind of a, so many of these guys now, it's I'm not very good with foreign names, but I believe that's Ankit Goyal. I will check with him to make sure that I get his name pronounced correctly. But he currently works for NVIDIA, but he's been involved with Microsoft Research and all kinds of other staffing positions. He's worked with Dieter Fox. Perhaps some of you might remember him. He's a professor up at the University of Washington that does some wonderfully cool stuff with robotics, and he's actually done a couple of talks to us over the years. So should be kind of interesting. I'm looking forward to it. Hope you are as well. And let's see, after the meeting, if there's interest and people want to hang around, we can just kind of have an informal chat. Usually shut the recording off at that point, so we just kind of have a talk about whatever, and that can kind of continue as long as people want to hang out. So no pressure on that, but it's in the olden days of our in-person meetings, that was sort of like the after meeting discussions. It's not quite the same, of course, because you could break up into various little groups and go and chat with 2, 3, 4 other people about stuff, but it's kind of a it's what it is, with the online world. And so with that, I am going to kind of turn things over to you guys. I'd love to hear about what sort of things that you got going. If anybody who's going to is building a robot for the upcoming Robo Magellan Plus or the SRS Build Challenge, you got anything that you'd be willing to share with us, we would love to hear from you. And anything else for that matter that's that you want to share. So I will open up the floor. Now, don't all talk at once. Come on, surely there's somebody that's got something out there.
Well, I don't have anything live, but maybe I can share a YouTube video. Hi, it's
Sure.
Brian. Can't see if I'm on video or not. I think I am. And
Okay,
so
let
I
me
don't
s-
think you can see me. I think I'm backlighted terribly here. But
yeah, no, that's
sorry about that. So I've joined this group at some points in the past, maybe every 2 or 3 months I might join, something like that. But yeah, I had put together a snake robot called Blackadder in the past. And yeah, that I haven't done anything on that for quite a while actually, but I also dug out an old project I had, which was a plot clock. And I'm not sure if I talked about that here before, but basically, okay, so basically it's a clock, but it's just it's a robot arm that goes and draws the time like on a whiteboard, right? So yeah, let me I should have found the link before I said, here, let me talk about it. But yeah, that's it. I'll put the link in the chat as soon as I switch on to YouTube here and go find my channel link and put it on there. But very short videos, 30-second videos, nothing long, just showing you know, some fun stuff I've been doing. So that's it. I'll put that up and we can talk about it later if there's interest.
you gonna dig that up, Brian? And then you don't have anything right at the moment to show us?
Yeah, it'll be there in 30 seconds. Just switching over to YouTube to get it. Yeah.
Okay. Okay.
Yeah, go ahead. If anybody else wants to speak, go ahead. I'll put it in the chat and we can talk about it after.
I'll just ask us a quick question while we're waiting. So I'm getting into CUDA programming, which is writing code that runs on the GPU. Is anybody in this group interested in that? Kind of a specialty thing. It's not going to go on a mobile robot for sure. Well, it actually could if you were running a like a NVIDIA Jetson or something. You would use it for that. Is anybody interested in that, or is it?
I'm interested in the concept. I looked up to see if I could do it on my iPhone or on my Mac, and
No,
yeah, well, it's not CUDA, but there's another language.
there is another language. Yeah. Yeah.
Interested, but haven't tried it.
Okay. Okay, cool, thanks. Won't worry too much about it for this group then. Find something else entertaining to do with you folks.
So CUDA is specific to Windows, right?
No, CUDA is specific to NVIDIA GPUs.
Oh, that's right. NVIDIA. Okay.
Yeah, so fundamentally, I think it requires an Intel architecture, although I'm not 100% sure of that. But it does require a NVIDIA GPU, which could be no, I take that back. It does not require Intel architecture because the NVIDIA Jetson runs ARM architecture. So, but it does require a NVIDIA GPU, and you know that you can get the NVIDIA Jetson boards. I think there's one now that's like $99 or $199, something like that. There's a fairly low cost entry point. And of course, these go all the way up to like the A100, H100 boards are like, $10,000 a piece. And you can put into, massive clusters and things like that. So it's an interesting technology.
I'm looking at, you say that space Y? Is that how you say that, Brian?
That's the one. Yeah.
Yeah. So it looks like you got, I see 4 videos on there.
Yep. Right. Yeah.
Okay. It looks like they're all pretty short. Okay. Let me switch over. switch over to that and share.
Yep. So the idea of this is just, it's a very simple 3 servos and an Arduino running this. So you'll see it does every minute, basically it erases. That's it. Goes on forever. Yep. And that's basically all it is. Two super well, three very inexpensive servos, right? 2 for the arms and 1 for lifting the table. And yeah, that's it. That's it for that one. Yeah. And the other ones are, yeah, snake robots. I'm not sure if I actually showed that here in the past, but so basically the snake is just, it's 10 servos. They're like in 5 are bent horizontally, 5 bent vertically, one after the other. And yeah, depending on the algorithm you drive it with, it has a whole bunch of different walking gaits associated with that. So again, that's driven by an Arduino.
Okay, so is that the third?
They're all the same mechanism. So you can look at the one that's the oldest, I guess, that shows the different types of movement.
Okay.
And then the one which is like the arm climbing one, that's another. It's like a helical kind of movement to crawl up something.
All right, let me. I'm gonna just keep. I let the audio on that video share, but as imagine it's just. Is there any commentary on there? Or
no commentary. No, you can. It's
okay.
just nice. It's just nice servo noises if anybody's into that.
Okay. I'm going to put this one up. I'll put it back up here. I've left the audio open to the mic, open to us. So, all right. So we'll click on that one. So
yeah. So the 3 segment snake. So this is basically. Oh, this one here. Good. So this is the basic. Well, this is the snake rolling around itself like in a helix, right? So you can crawl up something. So you get the idea that all that is 10 servos kind of linked together, and you drive each one with a sinusoidal type of a motion. And basically the algorithm is just giving phase offsets to each servo. You know, and that's pretty much it. You can play around with parameters, but you know, everything is just going in a sinusoidal motion. It doesn't look like it, but for all of these movements, it's just what kind of sinusoid you drive each individual servo with, and you get totally different type of movements associated with it. So that was kind of cool because it took me a while to, yeah, that's the same type of movement as that one. Exactly. Although a bit less of a budget associated with mine, obviously, but it's the same idea. So it's kind of fun to play around with that algorithm because it's not heavy at all, right? It's like I said, it's driven from an Arduino. It's not there's not much to it. So
yeah.
So if you look at my oldest video, you'll see the different types of sidewinder motion and that sort of thing. So yeah.
All right. Let me go. So one of the things, one of the questions that kind of comes to my mind, you know, like I've watched a number of these snake videos online, and of course there's always have a pretty sizable umbilical that ends up coming off the tail of the snake, you know, because it's hard to carry enough power in the form of the snake to be able to do what they do, you know. It's any good solutions, answers that you found to that yet?
I mean, honestly, yeah, you could. I don't think there's any barrier to driving this with a battery on each segment, like a small, like a LiPo battery that you'd normally use for a drone, you know, a small drone, you know. Basically, these servos they're serial servos, but they were cheapos from China, and basically I chose them because they were their voltage range goes up to 8.4 volts. So that's just 2 LiPos in series, right? And that's basically what I have on the end of my umbilical, is just two LiPos, larger ones though, driving the servos directly, right? Because I don't, that's a big problem with the robots, of course, all the time, is that you have power problems, right? So I don't like driving my motors through any type of voltage converter. If I can get it directly from the battery, that's the way to go. So these servos actually have an upper end of the voltage range, which matches up with, like I said, 8.4 volts. So that was ideal. Yeah, so I don't think there would be a problem with getting 2 small LiPos in each segment, honestly. Shouldn't be a problem. Just the cost of that, right? Which I haven't done. So
you got there's 2 more videos on here. Which
you want
one
to click the one on the right. Yeah. So that's showing the different types of gates or movements. So again, this is like, that's just a worm motion, right? So half of the servos are being driven and the ones going horizontally are not, just vertically. And then it's sidewinder here. So both the vertical and horizontal are being driven. Which kind of, it's kind of freaky when you see that, actually, because it looks scary. But, and this is something that didn't work out. That was a turning movement. And this is rolling, right? Which you don't see a real snake doing, but it's actually the most efficient way to move with this type of robot. It's like it's the fastest, and it uses like the least power. But yeah, so that's it. And the reason why, and these are the same movements, just with 3 segments. So I did all of this because I found a paper from about 10 years ago, a PhD paper, which talks about all the physics behind this stuff. And, and then he had the algorithms there, and, he had built some of these robots himself out of like metal and stuff like that. And I said, sounds like a good project. I'll just try to make one out of foam board and serial servos. So that's where it comes from. So these are the same movements as for the video we just saw, except it's the minimal configuration, which is 3 segments. You'll see it. So this is it rolling away. So with 3 servos, you can actually get all those movements. You can get like you can get sidewinder motion, you can get rolling motion, you can get turning motion, all this stuff. So that was just my attempt to replicate the minimum configuration. Yep, there you go. And and basically then the helix one, which is like climbing up things, is, let's face it, I wanted to reach that point of getting, helical motion to squeeze around something and climb up it, like an arm or a leg or whatever. And yeah, so that seems to work, except I need a few more segments on my robot, actually, so that they don't they can only bend 90 degrees maximum. And with 10 servos, you're kind of reaching the limit of how much you can bend around something. So yeah, so a few more servos would have been great, but that's all I had. So that's kind of where it sits now. I mean, there's a lot more you could do with that, but I kind of reached the point where I wanted, that the level of kind of movement that I wanted to see. Yeah, that's it. Fun to do, as the reason we're all doing this, right? So
yeah. It does, yeah. That's really cool. I'm impressed. Thank you for sharing that.
Sure.
Anybody have any questions or comments or?
Hello, can you hear me?
Yeah, Mike, go ahead.
Yeah, I just wanted to, hoping you could repeat about getting power directly from the battery instead of a regulator. Can you really explain? That was interesting.
Yeah, because I mean, typically, I mean, there's always a problem with current being driven by the motors or some high or a servo, right? Which is higher than you expect, because the ratings on things are never, I mean, they always say it's peak, 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 but we all know that's a bit of a fudge from every manufacturer. So you actually need quite a large voltage converter to provide solid power to a high current device like a servo or a motor, right? Higher than you would expect anyway. And it always causes problems. So to avoid that completely, it's much easier to just wire your components directly to a battery, if at all possible, right? And for a servo, that's the easiest thing, because it requires a certain voltage, right? You don't have to adjust the voltage to change the speed. That's what the servo does. So if you're providing a very stable power supply with high capacity current to a servo, that's when you get the best performance and you have the least problems. So that's the preferred method of doing it. So like even for a small servos, which, you know, can typically run on 5 or 6 volts, right? People would run that off of like a USB, you know, 5 volt type power as well. And that's great, except when you get to, you're still looking for problems doing that, because you're gonna hit, your components are gonna demand more current than your power supply can provide. And so either the voltage will dip, and if you're running off of the same power supply for your electronics, then, you know, they get glitchy. It's all these interactions which always cause a problem, in my experience anyway. So if you drive the best thing to do is have separate power supplies for your power hungry things and your electronics, right? That's the best way to do it. Then you just ground them together. But if you can't do that, the worst thing to do is to like have even a high capacity voltage converter to 5 volts and drive your electronics and your servos off the same supply, asking for trouble. Like, don't do that. So that was a big advantage of these servos, which I found, is that their upper bound of voltage was 8.4. You know, two lithium batteries in serial, perfect, right? Like that's just making life simple for yourself, I think, and I recommend that to everybody, because especially when you're doing things for the first time, you don't know where you're going to have problems, and damn it, if nearly everybody has problems with power, or things get glitchy, and people get frustrated, right? So avoid it. Just avoid the problem altogether. Have two power sources, one for your power stuff, one for your electronics, separate, and you don't have those problems.
Cool. Yeah, sounds good. Thanks.
Yeah.
That's probably well, what we would call it, you know, when people would bring stuff to demo at our in-person meetings when we were having them, and almost invariably you'd get weird stuff happening, and a lot of times you could trace it back to, oh, how are you powering your thing? Well, I got this one battery that runs everything, and you know, it's like guaranteed, right?
Yeah.
No, seems like no amount of filtering or anything else seems to quite do it when it comes to keeping the effects of those high power loads on that battery from getting into the delicate electronics and just completely hosing everything.
Yeah, exactly.
Yeah. All right. Let's see. Well, anybody else got something to top that? You know, I don't know. This is really funny, but when I saw your little time drawing thing on the little whiteboard there and everything on it, that somehow that made me think of Doug Bell, because I know Doug always loves to come up with really interesting ways to do things. You know, like building a clock. You know, we'll build a clock in a very unconventional way, like one that draws its time on a whiteboard. Why not? Right?
Yeah.
I've seen. I know Doug has shared with us some of the most incredible things over the years that he has created out of. You know, so
cool. Yeah, and I won't take credit for that one either. Like, honestly, I've seen some similar things were online, right? I'm not. But go ahead.
I saw somebody do something like that just had a little like a little pin that drew the time in the sand. And then it had a little sweep that would just sort of smooth the sand over. I think the sweep would go one way, and then it would draw the time, and then the sweep would go back, and that was how it worked. And I think it was like, once a minute, this thing would redraw the time in the sand. You know.
Yeah. Well, I mean, it's a pretty simple mechanism, right? Like if you look at
Mhm.
that video again, there's not much to it, but the result of it is somehow mesmerizing a bit, especially when you watch it for a couple of minutes and you're waiting for it to erase, you know. And
Yeah.
I had several years. I mean, I made that quite a few years ago, and I had it at a Maker Faire, you know, and that drew people, you know, standing around waiting for this thing to start erasing and drawing the time. And it's like, ooh, you know, it's like, okay, great. It's like, it's not that complicated, but it's different, right? And this is the thing, it's different, and you get something that you wouldn't expect out of it. So
Right.
Yeah.
Right. Yes. Yes. Okay. Well, does anybody else have something to share? I see our presenter has joined us online, so I would like to, if nobody has anything else to share, I want to go ahead and start our break, and we'll get our presenter set up here, and then we will proceed to the part 2. Anybody got anything? Going once? Going twice? Sold. All right. So let's see. Let's take about. Let's see. I'm showing. It's about 10:55 your time. So I'm thinking. Let's take about. Just turned over to 10:56. Let's take about 9 minutes. So 5 after the hour, we will pick up. And so feel free to go ahead and grab some coffee, hit the restroom, whatever you need to do here, and we'll be back in about 9 minutes or so. And I'm not certain how to properly pronounce your name, Mr. Goyal.
Yeah, it's Ankit Goyal.
Ankit Goyal. Okay.
Hey, hi, nice to meet you.
Yeah, it's nice to meet you too. Thank you so much for joining us. We're going to take this brief break here, and then we will go ahead and get you on there. Why don't you go ahead and just for the moment here, share your screen. We'll make sure that that's all working.
Yeah.
And I've got a slide that has a clock on it, so I want to put that up again, and then we'll bring you on just at the end of the break. Okay, that looks like that's
okay.
Yeah, that looks like that's working lovely. Yeah. Okay. All right. So I will. I'm going to go ahead and take it back. And thank you so much for coming, joining us here. This is it's a real pleasure to have people from all over, you know, sharing things. And we've the last few years we've been able to go to do these online presentations, and we used to just grab people local to Seattle. So we actually had Dieter Fox on. He actually joined us in a couple of times.
Oh,
yeah, and I saw in your background there that you worked with him.
Yeah.
And he's doing some pretty cool stuff. But since we switched to online meetings, we have been pulling people in from all over the world, and it's just been incredible the things that people have shared with us. So it's you know, so yeah, you're back in. Is that Princeton? Is that East Coast?
Yes, Princeton,
Yeah.
New Jersey.
Yeah. New Jersey. Okay. Yeah. So good. Wow. Yeah. Thank you so much, and I will introduce you. Let's see, what have I got there? 58. So what did I say? About 5 after. So got about a little less than 6 minutes yet. So I'm going to I might go fill up my coffee cup here.
Yeah, please.
All right, excuse me here. I'm just going to go ahead and shoot my. I'm going to turn off my video here and go disappear for a moment. So
Yeah.
Stuff that we want to haul on our bicycles, we want to drive. Okay. Oh, let's see here. All right, everybody. Gather back around here and we will go ahead and get our presenter going. And Kate, why don't you go ahead and share your screen, and let me see if I'll stop mine here. Let's see here.
Yeah, just
There-
share.
there-
Is it working?
Yep, we're seeing it. We were say Lloyd, you were we were talking about a programming language on NVIDIA.
Yeah, CUDA.
CUDA. Is that something? And Kate, do you know about you know much about CUDA?
Yeah. So CUDA is essentially the language that is used in GPUs. So
Mhm.
GPUs are these machines which are like, so you can think of as machines which have like a lot of cores. So instead of like CPUs which have like fewer cores, GPUs are these machines with a lot of cores which can do like a lot of parallel processing. And in order to program them, you use like CUDA. CUDA is the language.
That's the language. Okay, cool. Okay, well, I'm going to let me go ahead and give you just a brief introduction here. We have Ankit Goyal today. He is a research scientist in robotics at NVIDIA. He's working with Dieter Fox. He did his PhD in computer science at Princeton University, and then was advised by Professor Jai Dong. He's completed a master's from the University of Michigan and a bachelor's from IIT Kanpur. So he has been he's been involved with a lot of different things. He's worked at Intel Research or Intel, Microsoft Research India, and USC. So he's got a wide and broad base of experience here, and we were very pleased to have him today. And so with that, I will turn it over to you, Ankit.
Yeah, thank you so much, Stephen, for inviting. And it's like, it's nice to meet everyone and like present. Okay, so without further ado, let me start. So I'll be talking about some of my works, and like the general theme of the talk is towards building robots which are general purpose. So like, so as Steven said, I'm a research scientist at NVIDIA. I work at the Seattle Robotics Lab with Professor Dieter Fox, and I completed my PhD recently from Princeton University. So I come from a computer vision, deep learning background. So you would see the flavor of that throughout my talk. And the general goal is, how can we build robotic systems that are like more general purpose? They are not designed for one particular task or one particular object, but can do multiple things. And I'll be talking about those things going forward. And feel free to interrupt and like ask questions. Yeah. So essentially, the way I think about generality is that, at least here, I'll be talking about like 3 axes of generality that have been focus of my work. One is moving from robots that can do many tasks instead of just a single task. The other axis of generality is, can it handle unseen objects? So generally, in a lot of scenarios, the assumption is that you know the objects that the robot is interacting with beforehand. But like, if we want really general purpose systems, then they should be able to work with things they have not seen before or not interacted with before. And the third axis of generality is, can they understand beyond templatic languages? So by templatic language, you can think of it like a code or something which is like very specific to the robot. But can they interact with humans and understand humans in natural language, understand the tasks in natural language, and then do something? So these are like the 3 axes of generality. And here I'll be talking about, very briefly going over 3 works which lie at this different axes. So for example, RBT lies at like, is towards building systems that can solve many tasks. And IFOR is a work that's towards building systems that can handle unseen objects. And proc prompt is a work which is towards building systems that can handle natural language and unseen objects. And my goal in my research is going towards systems that can do all these 3. So that's like towards this general purpose robotic learning. So essentially, let's start with the first axis, and we'll see a flavor of what I'm talking about, like towards building systems that can solve multiple tasks. So here, what I'm showing is the same system, which is essentially the same model. Nothing is changed, only the input is changing, and it is this RVT system, or we call robotic view transformer, that can solve all these different tasks with varying level of success. So it can open drawers, put things inside drawer, can press sanitizer, uh, put things in shells, like stack blocks, all these things. And these are all, it's the same system. What's just changing is the input and whatever language command that the user is entering. So this is what I mean towards solving many tasks with the same thing. And RBT at a very high level, we design it, to give some background. So like, how do we build something like this? So here, what RBT is this key point based manipulation system. So essentially, let's say this is the scene, right? And the execution is like the user command is something like put the tomatoes on the top bin. Now, in order to solve this task, what the robot or the system needs to predict are these set of key points. So what are these key points? So firstly, it would need to go somewhere on top of the tomatoes, right? The other key point would be it needs to go and grab the stem of the tomato. And the third key point would be it would need to go on the top bin, right? So if a system can predict these three key points correctly, and let's say we have access to a controller which can like execute it, then we can solve this task. So this is like thinking in terms of like these key points or these bottleneck poses that the robot needs to achieve. And that is one of the key things that we do in RBT. So for example, what I was saying is that, okay, first the system says that you need to go there. The second key point could be something like, okay, you need to go on top of the stem, and then the controller would execute it. And then let's say the third key point is come back up or something like that. And then the system would just execute that. And the final key point could be something like go on top of it. So this is what I mean by key point based manipulation. Now, as I said, in RBT, what the system needs to predict are these set of key points. And now I'll go over the pipeline and like give some flavor of actually what is happening under the hood. How would we build a system that can predict these set of key points in order to solve a task, right? So the first, and I'll do this with, let's say, an example. So let's say the first stage of our system is everything is perception based. So in all of my work, I assume that no privileged information is available. The robot is just seeing, we just have some access to some cameras, and that is how it is observing the world, right? So the input is, let's say we have multiple cameras, these are placed at some places in the scene. So the input is multi-view or single view sensor data, which could be like image plus some depth sensor. So these are like Intel RealSense sensors that we use. Based on these multi-view input, what our first stage is that we combine all that input into one representation of the environment, and that representation is a point cloud representation. So what a point cloud is this, we can think a point cloud as a list of points, which each have like an XYZ value, which is like where the point lies, and an RGB associated with it. So given this sensor input, we combine all that sensor input to like reconstruct the entire scene in some way. And then given these point inputs, we have a pipeline of something called a rendering, which let's say, however the inputs are coming, what these renderings would do is based on the axis of the robot, it would align those renderings and like create these images, which are like, you can think of these images as being like images which are at these orthogonal locations. So these locations are orthogonal and they are like capturing like front, left, top, these different views of the scene. So these images are like rendered using these images are like, we render these images using some mathematical operations here. And then we have all these images. We feed them through neural networks. So these neural networks essentially are a particular kind of neural networks which are very popular nowadays. So these are called transformers. So your GPT-4, the underlying neural network is a transformer. In ChatGPT, GPT-4, all those is a transformer. So that's the same architecture that's here. We call it multi-view transformer. Essentially, what this multi-view transformer is taking is it's taking the language. So for example, we have some way of specifying the task in language, like put this spoke somewhere. And then we have some tokens which are coming from language and tokens which are coming from all these images. A token can be thought of as a word. Right? So we have these tokens which are coming from language and tokens which are coming from images. These image tokens will become clear later on. And then we take those tokens, we pass it through this multi-view transformer network, which is essentially a neural network which takes all this information. And what this neural network spits out are these, let's say it takes these tokens, and what this neural network spits out are these heat maps across all the views. So essentially, we have this transformer model which will take these tokens and then it will spit out some heat map locations, which says that, okay, you have to go on this image, you have to go here, on this front image, you have to go here, on the left image, you have to go here. And once we have this information, it's easy to just back project them. So like take all this information, back project and get like some 3D location where the robot needs to go. Right? So this is essentially very high level idea of like what's going inside the pipeline of how we do this 3D key point based manipulation.
I have a question for you.
Yes, please.
Is it 3 cameras, an X, a Y, and a Z axis camera that's gathering the video, the visual imagery?
Yeah.
Just 3 cameras then?
Just 3 here there are just 3. Actually, in the real world execution that I showed, this was just 1 camera. So it's just the front camera.
Okay.
Yeah.
Okay.
Yeah, so let me give some more flavor as to like, okay, what is happening inside this neural network, how to connect the dots. Right, as I said, we create this point cloud representation, right? This is essentially coming from the RGB and the depth. It could be 1 camera, multiple cameras. Right? We create this point cloud representation. And then we have some way of rendering different images from that underlying 3D representation. So we can get a top view, left view, right view. Right. So these are some views that we can just render from that representation. There is something, and also what I said was we have an architecture very similar to what is used in ChatGPT, right? This is an architecture which consumes words and then gives out some words, right? So it takes language, gives out language. But if we want to use the same architecture for images, how do we do that? And for that, there is something called a patchify operation, which is essentially you take those images, you break these images down into these constituents. So let's say this image, each of these images I've broken down into 3x3 blocks, for example, right? And then once you have those images, each of this particular block can be now thought of as a word in vector space. So you can flatten out the RGB values in the image. You can pass it through another neural network, which converts them into this vectorized words, word representation. So now I think the way to think about this is that each image can be thought of as a sequence of words, where a word represents some patch in that image. And now this entire problem becomes these set of images are now, let's say, sentence 1, sentence 2, sentence 3, sentence 4. We also have a sentence, which is the input task, right? For example, here's insert peg in the blue spoke. Right? So this is a sentence. This will give us some tokens. Each of the images would give us some tokens. We pass it through this multi-view transformer model, which is very same as like what ChatGPT does. And then it gives us a set of tokens. And the set of tokens essentially tell us, okay, in this image, in each of the image, where should the robot go? So it's taking these sentences, converting them into these new sentences, which tell us where should the robot go, right? And in each of the images. And then from that information, we can back project and get the 3D location where the robot should go and what should be the pose of it. So there's like some decoding step going on, but it in some way, it's still like going from some sentence to another sentence prediction task. So that's like, hopefully that would give some information about like what's going under the hood. Probably not very interesting slide, is essentially saying like what existed before. We could like improve upon that, improve on performance and stuff. I think this would be interesting. It shows like all these predictions. It's the same model which has been like trained to do all these tasks, and like you can see I am like moving things around, giving it a new task, and then essentially it is able to do all these things. And the input is just coming from like a single camera here. So I can like move around something. Sometimes it will succeed, sometimes it will fail. But essentially it's towards building systems that can do like multiple tasks instead of like just do a single task. Yeah, I'll be, are there any questions before I move on to the next part? Okay. Good. Nice. So let me talk about some other axis of generalization, right? So the one axis of generalization I said, well, okay, how do you build systems that can go from single task to many tasks? Another axis of generalization could be how do you build systems that can work with unseen objects? So here, even in my previous example, you would see there is the same set of objects that the robot has seen before. But now we want to explore systems that can work with objects it has never seen before. So for example, here, we essentially studied in this problem of robotic object rearrangement. And so essentially here, the input is a goal image, which has like objects which the system has not seen before. And what it needs to do, it needs to like rearrange the current scene into this kind of goal configuration. So that is essentially the task. So here, these objects are like not seen by the system many times before, right? And this is our system, and it works with like a single camera placed in the front. Now, how do we do this? Let me give you some flavor of that. So essentially, this task of rearrangement, that is like going from the current scene to some goal image, this can be thought of as the task of predicting rigid body transformation. So what I mean by that is that, okay, this box needs to be transformed into this configuration. So it is going from a particular configuration into the, if a system can recognize this, then it can kind of solve the task. So it needs to recognize, okay, this is how my current scene looks like, but okay, this particular bottle or spray bottle needs to go into the new configuration in order to, so this is what the system needs to predict. And how do we do that? So to give like a very, very brief overview. So let's say the input is some goal image, which is like fixed, and the current scene. From that, what we do is we predict two things. One thing that we predict is a segmentation. Segmentation essentially tells, okay, what are the objects in the scene, or objects of interest in the scene. So this segmentation will tell us, okay, there is a box here, there's another box here, and there is a bottle here. So this is what this segmentation tells us. And there are like tons of different networks or neural network techniques to do this particular task. We use one of them here. The other thing that this system predicts is optical flow. So what optical flow is, okay, it's telling us where are these pixels flowing in the scene. So it says that, okay, these pixels are flowing here, this particular box is flowing here, and this. So it's essentially giving us at the pixel level or at the point level, where are things moving so that they would match. We also have access to depth. So we use RGBD sensors to get some depth. And then we solve for the rigid body transformation. As I was saying, so we know the flow of pixels, and then we solve an optimization problem, which essentially says that, okay, if all these pixels have to go from this location to this other location, what is the rigid body, what is the transformation of the object that I need to do? What is the 3D location change and the rotation change that I need to execute in order to move this, in order to move these pixels from this location to this. So it's essentially, it solves that optimization problem using like some standard techniques in multi-view, using some standard geometry techniques and some standard algorithms called ransack. And then we essentially, what we do is we ask the robot, okay, now you execute one of these possible transformations. So what would the robot do? It would take, let's say, here it selected the orange bottle, and it would make this transformation. And again, we'll repeat the same process. So again, this entire thing would go in, it will create segmentation, optical flow, and then predict, okay, now again, and this is this iterative process of like, until and unless the robot says, oh, all the pixels are not moving much, there is no much transformation, and then we stop. So this is the iterative process that goes on in the system, and then can handle unseen, it can like rearrange unseen objects. So,
I have a question.
Yes, please go ahead.
So can this system handle if the initial configuration of the objects is such that they are in the positions of the final configurations of different objects, so that you have to move them out of the way in order to start working? Does it do that?
Yeah, it can do that. So essentially, we have like a few more things inside that I didn't talk about here. So essentially, when we say that it needs to execute its transformation, we have like a collision checker, which checks that, okay, if I do this transformation, will it collide with something else, right? And if we find out that it will collide, then we not execute. And now suppose in your case, as you said, is that everything is colliding in the final configuration with something else. Then it just takes a random action, a random execution where it moves one of the objects away. And when it moves one of the objects away, then it clears up the space for at least one of the colliding thing. And then again, this pipeline can proceed.
Cool.
Yeah. So the cool thing about this work is that everything you see, the training part, or where we are training this optical flow or segmentation, everything was done with just synthetic data. And we directly execute this system in real world in zero shot. So these are like some of the synthetic samples that we generated using like NVIDIA simulators. And then we train our system to do the optical flow segmentation, everything execute. And it does that in real world without any changes. So we don't make any change to the system, and it can do all these tasks in zero shot. So here I'm showing another execution of the system where it is trying to rearrange these bottles. Yeah. So this is like a simple iterative procedure. It might make mistakes sometime, but then it can keep on going unless it feels that, okay, all the pixels have been mashed and stuff. So here you can see it makes a lot of mistakes, but eventually it comes to a configuration which is pretty close. And here, the thing to note is that it has never seen these bottles before, and it has never seen anything real before. Everything was whatever neural networks we trained, it was done in simulation, and we just execute it directly, and it can do a like decent job at that. Cool. I can take any more questions here before I proceed to the final part of the presentation. Okay. Great. So since there are no more questions, let me talk about third axis of generalization. Like, how do we go from building systems that can understand natural language, like the way we speak, as opposed to like some kind of templates that for example, in my previous RVT work, you could see that, okay, it's not very natural. It has to be like in a certain format for the system to work. But like, how do we go towards building robotic systems that can understand any natural language? So this is the work prompt assess. Essentially, it's relying on large language models, and so this work shows how can we combine the power of large language models like ChatGPT with robotics to understand tasks and stuff. So I'll go over more details, but just to show the video again, the task could be something like sort put to the fruits. Then it could like understand, okay, there are multiple fruits and I need to put this thing here and be on the plate and put the bottle on it. So let me give some more details what's going on here. Let's say we have a task, make coffee, right? and we have a prompt. So like, let's say we have prompt like this, like make coffee, and these are like this is a plan to make coffee. And now we tell the system, okay, when I say make coffee, this is the plan. Now, if I say microwave salmon, can you give me a plan? So this is how you would like query something like ChatGPT. And then what ChatGPT would do, okay, it would complete this task and would tell you, okay, if it is make salmon, these are like the steps to follow, right? How could we use something like this in robotics? Like directly using this kind of a system has like many issues, right? The large language model, since it is just language, it's not actually situated in the scene. So it does not know whether if I have a plate or not, or like what kind of microwave I have, right? So it's not seeing anything, it's just taking the language. And then the commands it's saying, they might not be available, right? For example, maybe my robot cannot pick up salmon, or maybe my robot does not have a particular kind of capability. Then how would you still execute, right? How would you map whatever the language that this model spit out into like actual control actions? So this is like a problem. So I guess like in a quick summary would be the LLM, firstly, it's not seeing anything, so it does not know anything in the scene. And second, it does not know about the capabilities of your robot. So this creates like two problems, right? And how do we bridge these things? So we did a clever trick. So these, if you try these LLMs, they're actually equally good at filling in code. So they might be trained on like lots of language and lots of code, and they're good at like filling in code as well, right? And so we found that how do we codify our task? So it could be good to go from natural language to actual code, and then ask the language to fill in the code instead of asking it to fill in the language, and that gives it's a lot of structure. So in the code, what we do is we first, so this is the input to actually, let's say ChatGPT or something. So here we would say that, okay, these are the actions that my robot can execute. So this first part is like, I can only do grab and put in grab. So these are like the capabilities someone has like made controllers for them. These are the capabilities that the robot could execute. And then given the function, so then this is a function call, and it's giving the LLM example. So let's say if I tell you throw away bananas, and the objects that I have in the scene are like banana, garbage can, then what you need to do is you need to grab and put in the banana in the garbage can. So this is like an example I give the LLM. I give it more examples, and then finally I give it a new task, like sort the fruits on plate and bottles in box. So like sort things out. And these are the things. Then the LLM, based on what it has seen so far in the prompt, would like give us, now it would give us actions. Firstly, it would give us actions that are based on in the code, right? So it will only give us actions that the robot can execute, since we specified it in the code. So it will only give us actions like grab and put on, things like that, because that's the input to the LLM. We say that, okay, these are the only actions you could do. And then we also told the LLMs the objects that are present in the scene. So in some sense, we are giving it the ability to see. It knows that, okay, there are only banana, bottle, boxes, and things like that. So it can only now do things with it. So it will grab, put on banana in the plate, and this is how it will fill in. And we will now use this task, and execute it on the robot, this set of instructions. To go into more detail, what is this prompt, right? So essentially, this prompt has the input to the LLM has these components. The first part is the action specification. This is essentially saying these are the actions that the robot can execute. I have made the controller for the robot. It can grab anything, put in somewhere. It can switch on, switch off something. It can open something. These are the actions it can execute. Then there is this environment specification, which is essentially what are all the things in the environment. There is a banana, there is a garbage can, and things like that. This is like another input. And then there are comments. So these comments are there's something in LLMs. If you also give them comments, like okay, which kind of like help them reason, that also helps them give you right set of actions. For example, here we have a comment like put banana in garbage can, and then some specification. So if we have these kinds of comments in our input to the LLM, then it is generally found that they would give more reasonable output. And then there are some other bells and whistles, assertions, and things like that. So assertions are essentially before doing something, you have to assert that. For example, before switching on something, you have to assert that okay, it's off, and things like that. So these are all other things that we have in the query. And here I'm showing the execution again. So let me just pause first part. So here the input to the to this LLM is the sort the fruits in the plate and the bottle in the box. And we also have our prompt, as I said before, like this, where we take this input specification and then whatever is visible, we convert it into a list, a specification. We have like some capabilities which we know the robot could do, like grab something, put on, and all those kinds of things. And then the LLM fills in the rest. So it says that, okay, I can see a banana, put the banana on the plate. I can see a strawberry, put the strawberry on the plate. I can see a bottle, put the bottle in the box. And once you do this, you're done. So this is, in this way, what we have done is we have converted this language specification problem into like this code filling problem, and that becomes easy to execute on the robot. So this is a very simple idea that it tends to work really well when we are trying to integrate these large language models which can understand language really well with robots, which have to be like specified in a very specific way. Right? So hopefully that gives a flavor of how are we thinking about like building systems that can understand natural language instead of just some templated commands. So that's it actually. That kind of like covers all the access that I wanted to talk about here. And I'll be happy to take questions, go into more details about any specific topics people are more interested in and things like that. Thank you.
For the task planning, is that like a single shot or is it iterative? Like, do you update the prompt with what is in reality or what is changed in reality?
Yeah, so it's a single shot. So essentially, the LLM just fills in everything and we just execute it. But there are like follow-up work which try to also do like in iterative fashion. So they would like now rewrite the prompt with this new current execution and then try to do it. So it's, yeah, that's another way of doing it.
So, so are the on this particular slide here, so the comments that, you know, the number 1, number 2, are those used by the system in some way, or are those there for you as a human to understand what you're asking the robot to do?
Mhm.
Or is it just taking those comments and just transferring them over as text comments, or is it actually like using the information in those comments somehow?
Yeah, so essentially, it's actually using the information on those comments. So it's because LLMs are very good with language. They're good with code, but they're also very good with language. So if we give them some examples that, okay, this is how this language translates into the action, then when they are giving out outputs, we find that they are better. So it's because it kind of like gets the language connection between, like it gets the connection between the language and the specification. So we have generally found that if you just, for example, just with ChatGPT, if you give it any task, and if it is not performing well, just give it some examples with explanation. So this is like kind of an explanation, and you would find that it starts performing well. So this is just a quirk of LLM. So when you give them the explanation, then they would also, when they are giving the output, they would give you the explanation, and generally the output is better. So it's kind of doing that task.
There's a question in the chat there. Do you have your chat window open?
Oh, how much memory? So here, essentially, the LLM is not on the robot. We query it on the server, and we just use the output. So it's like just querying from the internet, and then because it's a single shot thing. So, or even if it's multi-shot, you can just query it and then use the output and execute it. Yeah.
So this makes me think that like if you're like using chat GPT or something like that to create programming code, I grew up with the idea, you comment your code so when you go back in a month or a week or 2 hours, you know what it was that you had intended your code to do. But it sounds like the new engines out there can actually take the comments and use them to tweak whatever result that they produce. Like if it produces programming for a particular processor, let's say, maybe so you can actually make better code, or maybe make code that does closer to what you actually want because of the comments in there that were there, maybe there for human purposes, but also help ChatGPT. Is that kind of what's
exactly? You're right. Yeah.
Wow.
So these explanations kind of also the ground, right? Because they also, like as humans, right, they help us understanding, okay, this block of code is doing this thing, right? It's kind of like at a high level explanation. And these systems also benefit from that. If you have these things in the code, then it kind of like helps these systems to even fill in the code.
Wow. I had no idea that things had moved that far. That's pretty cool.
Yeah.
Any other questions? Well, I think that's probably it. All right. Well, thank you so much, Ankit. This has been really interesting. Let me turn my camera back on here so I don't have to look at my cat there. That's my old guy. He's that was a kind of one of those pictures, that just happened to be taken. I've started using this thing all over the place for my profile pictures and stuff. So he's yeah. Anyway, thank you so much. Yeah, it's a great talk. I always learn about a whole lot more than I expect from these things. So appreciate your sharing this. And that I liked your 3-dimensional, graph there, that was kind of at the very beginning, that was a cool way to look at, you know, the essentially the 3D mapping space of creating the functionality of a robot. So that hadn't thought about looking at it that way before, but that's kind of neat. Yeah. So, and let's see, is anybody else have anything? I'm going to, if not, just kind of some general housekeeping. Will be the same Zoom link next month. So that's always posted on the website, and we'll have the YouTube video and the chat text and all that posted here sometime probably in the next week or so. We'll see. I'm going to be traveling next week, but I will probably have my computer with me, so we'll see what I get done. And do keep your eyes open for good presenters like Ankit, and we will. I'll try to reach out to them, and we'll get some more of them. And is your presentation? Would your presentation be available to post on our website, Ankit?
The video or like the slides?
The slides, that would be sufficient.
Yeah, I think it's a slide.
Okay. Yeah, if you could just send that to me, that would be actually, if you could make a PDF of it, if that works. I don't know.
Yeah, I'll make a PDF of it. Sure.
Okay, that would be great. And with that, anybody else have any more? If there's if not, I will bid our presenter a good day, and thank you so much again.
Thank you so much for inviting. Yeah.
Yes, appreciate you joining us. All right.
Bye.
Thank you.
Bye, everyone.
And is there, does anybody want to continue to chat about anything in particular? I can, let's see here. I can back up right there. So if there's any interest in post, talking about what our presenter presented, or any other anything else in the realm that you want to chat about? So, just as maybe just to kind of hit our poll point way back at the beginning of the meeting, when we were kind of looking for, how many people would be interested in, how many people really want us to go back to in-person, or who would come regularly to in-person meetings, just so we kind of have an idea. And Lloyd had suggested just doing a raise your hand, and there's, if you right click on your there's a reactions button if you don't see it, or a more button at the bottom of your window. And if you hit reactions, and then there's a raise your hand down there. And if you guys, anybody who would be willing, anybody who's interested in getting together in person, do that right now. Go ahead and raise your hand, just so we kind of have a feel for how many. Okay, let's see, Jim. Who else we got? As you may recall, it looks like the room could probably accommodate about 8 to 10 people at the most. So if we're looking at more than that, then we would probably need to find a way, or better way, to accommodate more people. Let's see here. It doesn't look like, okay. Oh, I guess I'm looking at the whole, what do we got here? 1, 2, 3, 4, 5, 6. Okay. All right. So it seems like at least I think we're probably gonna try to move toward in-person meetings. I know I do miss those, actually, but I don't know. I don't live in Seattle anymore, so I won't be able to come. Unfortunately, I'm gonna have to be one of the Zoomers. But if you don't mind, Jim, I'm gonna go ahead and mute you there. I think it sounded like, yeah, got stuff in the background there. So it's I think that there's just definitely value in getting together in person and being able to bring stuff to meetings to show in person. And so I think we want to try to do that. but it's going to be on other people to kind of make that happen, because I won't be there for that. I might maybe be able to run meetings remotely, but I think in general, it'll be probably more people will still be coming in online than coming in person at the beginning, and then maybe that'll change as we get that figured out, and hopefully will be a good experience. We've done a little bit of research on other groups that have done hybrid meetings to try to figure out how the best way to do that. It's not everybody does it really well, and to make it inclusive for the people that are coming in remotely, so that they can hear and see what's going on in the room. Because as soon as you start getting very many people in front of a Zoom computer, it gets to be harder. They get spread out more, they're further away. It gets to be harder to understand people if they're too far away from microphones, things like that. So we want the experience to be good, and for you to be able to hear and understand and be able to participate in what you're seeing and hearing. So it may take some experimentation to kind of work out all the kinks to that. So do be patient with us as we try to figure that out. And are there any other questions, comments? Does anybody want to hang around for some more robotic stuff?
Jim has a hand up.
What's that?
Jim has a hand up according to the.
Yeah, that was Jim. That was when I was asking about who would come to in-person meetings. You would probably come, right, Doug?
Yeah, I'd probably come.
Yeah. Okay. I'm thinking, we're still probably. Is that Robert?
No, it's
Jim.
I have a comment. Our ham radio club just went back to in-person meetings, and a lot of people were doing the same thing. They didn't know if they wanted to or not. But once we've gotten together a couple of times, they're all saying, "Oh, we missed the in-person talking to each other and stuff." And so it's actually worked out pretty well. We went from about 10 people to about 30 people in the last meeting. So, but you say the room is rather small.
Yeah. It's just an office that's kind of, it's a walled off office in one corner of this 11,000 foot warehouse. So the warehouse itself is huge. If we could use that year round, then that would kind of sort of solve that issue. But the problem is there's about 5 months of the year when FIRST takes over that entire space, and so the only place that's available 12 months of the year is the office. But I don't know if it would be possible, if there might be other ways to get more people in there or not. As I recall, it's not a very big space, and there's furniture and other things in there. So it's not like it's just an office area that's open. It's like there's a conference table, there's television equipment, there's desks and office chairs and other things. So there's only so much space available. And if our meetings were to go much above 10, we would probably really be squeezed tight into that space. So I don't know what's a good answer to that. Maybe it'll take a while to get there. I don't know.
Well, has anybody looked at any restaurants that have like banquet rooms? That's what we do a ham radio meeting now, is talk about Andy's in Olympia, and there's enough of us now, they'll actually send a waiter in to take our orders and bring them down to us during the meeting. So if we, our meeting starts at 10, if everybody showed up at 8:30 or so and ordered their food at a restaurant someplace that's a banquet room, just an idea.
Sure. Yeah, I guess it would be kind of finding a restaurant that would be willing to work with the club
I mean, they don't charge us for using the room because there's enough of us to order food that
Yeah.
they, you know, they're happy to do it actually.
Yeah. You meet there once a month?
Yes, we do.
And you meet there on the same day each month then? The same
Yes, third Wednesday of every month.
third Wednesday. Okay. So,
But
yeah,
I mean,
so
you know, I don't, you know, I don't know if you could find a restaurant somewhere around Seattle that would do that for us.
yeah. There, I remember when we were meeting at Renton Technical College, some of you might remember that there was what was it? Was a pizza place, I guess, that was not far from Renton Technical College. And although that was not our meeting place per se, but we would go over there for lunch after the meetings. But they actually, I think they finally went out of business or something like that. I think that place is actually gone completely. But
Well, that
yeah,
some places
we
open in the morning. Pizza places
Right.
usually aren't.
right. And we would need it. Yeah. And we would need a place where we could have a good 2.5 to 3 hour block of time in their facility and a separate room, because we've got, you know, we'd have people talking, and it does make a little more setup on the part of whoever's running the meeting, because of course you know, that kind of a place is not going to have a preset a video streaming system. So then that would require somebody bringing that equipment in, setting it up and operating it during our meeting. So it does make a little more work on that end, which, you know, I knew about that. I did that for a long time. So I can talk all about how much effort that can be, depending on how much stuff you got to set up.
Yeah, we start showing up about 5:30 in our meeting rooms from 7 o'clock until about 9 o'clock. So we have a good 4 hours of that room, but nobody else uses it during that time.
Yeah. Well, that might be a possibility. You know, that can certainly throw that out there and entertain the option. I know there's different, you know, some folks would like it if we were further north. Some other folks would like it if we were kind of maybe north and east, you know, more, and places like that. You know, we've looked at libraries and, you know, public libraries. Most don't want to commit to, you know, commit their facilities to like the same, you know, of that same block every month. They like to have that flexibility to be able to allow anybody to get in there. And that makes sense, because, you know, there's like, why would one group have priority over anybody else as far as using the public library? I mean, it's something, place is supposed to be open to everybody. But a lot of libraries now have AV equipment in conference rooms. So, you know, in that regard, you know, doing Zoom meetings and such from a library's conference room would be relatively easy, because they have most of that equipment already available, and we could probably run something out of there with very little setup and configuration for our stuff. So, but having a consistent place and time is an issue with that option. Other venues a lot of other venues charge. Community centers tend to charge for their space, but they have similar kinds of things. I'll say, Bob, thanks for all the makerspace info there. It looks to me like there's enough of them out there that I should probably try to I'll make an extra page on the website with just that stuff. I had no idea there were so many, and I noticed the one you popped in there here in Boise, so I'm gonna have to check those guys out. So yeah, so, you know, we're kind of open to what works. The nice thing about the first facility, at least in the times when the warehouse space is not being used, is that it gives us an indoor space, a large paved indoor space, which would be ideal for doing contests and our own events. You know, running something like that at a restaurant, chances are, unless it's a really big room, might be a little bit of a stretch to be able to set up things like say for example, the Pop Can Challenge arena, or even a line maze arena. They can take pretty sizable amount of space. Sumo is pretty easy.
Well, is there a place we could go to afterwards, like after the meeting, and have a contest? Could we use that space, like, you know, on a as needed basis? And just have the meeting at someplace else close to it?
I don't know. Maybe.
By the way, I'm retiring at the end of the month.
Ah, finally, huh?
Yeah. 40 years is long enough.
40 years, yeah. I said 35 when I did it, so I you know, I've been out in the range for what, 3 years now? Let's see, it's 2023, 2020. Yeah, in fact, it's just over 3 years. I think at the end of May in 2020 is when I bailed, so out of Boeing. So I've been loving it. A lot of traveling, just it's nice.
Yeah.
I really like not getting up at 5:30 in the morning.
I hear you there.
So, okay. Well, anyway, enough about that. Anything else? Anybody wants to? I know, you know, Doug. You always had something really interesting that you would bring to meetings. Some of these really unusual and very kind of out there projects that you're working on. And I'd love to see if I don't know if you've completed any of those that you'd care to show sometime. I'd love to see some of that.
Well, I've kind of filled the house with junk, and so I don't have room to work on anything. But we've been working for 2 years to try and clean the house out and put up some sort of a desk that I can actually build something. But right now, I don't even know where everything is anymore.
Yeah, that does sound like a bit of a problem. Oh, you know what? I didn't. Oh, well, we've had I guess usually the post-meeting stuff, I stop the recording, but you know what? I forgot to do that. Oh, well, is there, I don't know if there's, I think there's nothing else here. I just go ahead and wrap the meeting up and call it a month. Anybody got any last minute volleys to chuck out there and maybe keep us going for another 15? I know that can happen sometimes. All right, well, I'm going to go ahead and stop recording.